Hi, I'm going to present the paper How much temporal long-term context is needed for action segmentation. In this paper, based on our finding on temporal long-term context, we revisit how temporal attention is modeled in transformer architectures for temporal action segmentation. In order to understand the impact of the window size on temporal action segmentation accuracy, we analyze the impact of the input size window on datasets such as Assembly 101, which contains long videos of assembly tasks where an action label needs to be predicted for each frame. This video shows the comparison between model performance for different sizes of input window, where 100% means the model has seen the full video, in contrast to, for example, 50%, where a window of roughly half the input size is given to the model as input. In other words, these percentages shows the different amount of temporal context given to the model. As these results indicate, modeling the full context of the entire video is very important for temporal action segmentation. Here we can see the quantitative results of our analysis on the impact of using the full sequence as input compared to using a temporal window on two datasets with long windows. We report the window size as a percentage of the average length of a video in the corresponding dataset, and 100% means that the full sequence has been used. For this experiment, we train the model either on the full video sequence or we divide the videos into shorter sequences, where the full context is lacking. The results clearly show that the full context of an entire sequence is advantageous over allowing the model to see only a window of the input sequence, even if the window is large, such as 50%. We can also observe that our approach benefits more from the full sequence than AS former. Based on this finding, we propose a multi-stage architecture that combines temporal convolutions and self-attentions. Each stage consists of multiple blocks. Here we use n equal to 9. And each block applies temporal convolution and the two types of attentions, namely windowed attention and long-term context attention. Here you can see an overview of the attentions. Since applying attention to long sequences such as untrimmed videos is impractical due to the quadratic complexity of the self-attention blocks, we combine windowed attention where we divide the sequence into small windows and compute the self-attention over each window, and long-term context where the video is subsampled with different offsets and the self-attention is computed over the subsampled sequences. The approach achieves state-of-the-art results on breakfast dataset and 50 salons, the standard datasets of action segmentation. Here the most reliable measure is F1 score, especially the F1 score with overlapping threshold of 50%. Here you can see the result on Assembly 101 dataset, which is the largest dataset among the three datasets. It contains videos of people assembling and disassembling 101 toy vehicles recorded in the setting with 12 camera views, including egocentric view. Our model achieves the state of the art while having less parameter and being faster than transformer-based methods.